The objective today is to explain what the Intel manual says about SSE Packed Arithmetic Instructions, amongst other instructions actually. We'll go ahead and finish this section off in this video. You see, we'll get down to this MXCSR register, and then there's some 64-bit SSE stuff, but after that it's all SSE2 instructions from here on out. So yeah, let's go ahead and wrap this up, and we're on page 126. Oh, I lie, 125. Last time, if you remember, we talked about just what SSE is, just like a general introduction. And then to cap that video off, we just, reviewed what the data transfer instructions are for SSE, or I should say the SSE instruction set. And if I had to pick a favorite for no reason at all, this move MXCSR, that's a long instruction, that is to extract a sign mask from 4 packed singles. So I suppose just the word extract kind of made me think of that Ghostbusters trap over here. I missed the opportunity to put a really cool picture in the last video, so I wanted to start this video with that. So what should I call this video? I am not sure. We're going to go over so many instructions that I came up with this idea. Since many of the instructions have to do with packed bytes, I thought of the Green Bay Packers. We'll call this video PACcmpLSU. LSU is another reference to football there. All because the first set is about packed arithmetic instructions. Then we got our comparison, so there's the CMP part of it. Guess I'm using P twice. There you go, maybe that looks cooler. The next up is the logical, the shuffle, and the unpack instructions. So see, Intel, you're not the only one who can play these strange mnemonic games. A good example would be like this first one, where add is the entire word actually. And then the P and the S would stand for packed single, as in single precision. So there's add PS. And a lot of these instructions seem to come in twos, so the second one is about scalar single precision floats. When you want to add those, you would just type in add SS. I'm going to try to stick to the manual, but I really want to make sure you know the difference between packed and scalar values, so if not, go Google. And just some quick Google advice. I'm surprised how many people don't have a strategy for learning complex new things. Here's my strategy. If you're a visual learner, which I feel like sometimes I am, you would Google the word and then click the images tab and look through those. If you're a reading learner, Wikipedia, random blogs are pretty good. Social learners, you can Google the term you don't know, but put the word Reddit after it, or Stack Overflow, or Stack Exchange after it. And then some days I have a hard time focusing, but if I force myself to write down what I'm trying to focus on, somehow I walk away with that knowledge better. So just some quick advice. Let's get back to the manual. It says sub PS for subtract packed singles. Following the same pattern as before, sub SS would be to subtract scalar values. Same pattern, mulp S, so multiply packed, and then moles, as in multiply scalar single precisions. You could divide packed ones, you could divide scalar ones, and that's pretty much it for that first part. Those are the basic arithmetic instructions. So I ask, what are the 4 basic operators of the SSE Packed instruction list? I find that kind of funny that they title it Packed Arithmetic Instructions, while the scalar is right behind every single packed one. So Intel, fix your titling strategies there. Well, now we get into this whole compute section, and if you don't know what a reciprocal is, you should do that too. Use that Google advice. So here's a question to respond to. What are reciprocals? And you can type in programming or FP values right after that. Well, we got RCPPS, RCPSS, square TPS, square SS, R squared TPS. Oh, I'm saying those wrong. So square root PS, square root or SQRTSS. I wonder how people pronounce these mnemonics. Like, I've been hearing MOV for move on a lot of YouTube channels, and I don't know why. I guess it's like really speaking a whole nother language. But anyways, those are the whole compute reciprocals part of arithmetic instructions. This section ends with a max packed singles, max scalars. You got minimum packed and minimum scalars as well. Alright, so let's get down to the comparison instructions. It says SSE compare instructions, compare packed and scalar single precision floating point operands. So CMPPS to start with, CMPSS. CommISS is an interesting one. This is where you're going to perform an ordered comparison of scalar singles and set flags in the Eflags register. So a good question would be, which instruction involves comparing scalars then setting flags in Eflags? And the answer would be commis, or commis, however you pronounce that. And it looks like it's almost opposite is the ucommis, as in you're going to perform an unordered comparison now. So a question I truly don't know the answer to, why would we need an ordered versus unordered comparison? Alright, on to our logical instructions. These are pretty straightforward. And PS, so you're going to bitwise logical and packed single. Then we have and NPS, as in an and not. The next instruction sounds cool, ORPS. There's a logical OR of a packed one, and then XORPS, it's an XOR of a packed single. So there you go, not much to say about those logical instructions. Now shuffle and unpacked sounds fun. There's only 3 instructions here. We got the shuff PS, as in shuffles the values in packed singles. It kind of reminds me of a Sesame Street character. Shuffle-uffle-I-guess or something. But it's just a cool instruction name there. And then the last 2 instructions are pretty long ones. So basically though, unpack high packed singles. And the word interleaves is so interesting. If you Google it, you'll basically find out it means to insert or connect. So if we unpack and interleave the 2 high order values, that's what we're doing with this instruction that ends in HPS. The second instruction ends in LPS because we're going to look at the low order values now. But let's come up with a question. So what does interleaves mean in this context? And another good question, since these 3 instructions were just thrown in together, what are the 2 types of unpacking that these SSE instructions do? And the answer I'm looking for is like these high order values and low order values unpacking and interleaving. Now onward to our conversion instructions, and I think in general this is all about converting packed to scalar. So the first very long instruction, CVTPI2PS, this is convert packed double word integers to packed singles. Next we can convert the double word integer into a scalar single precision floating point. Now the next one's tricky because instead of going from double word to a single, we're going to go from a single to a packed double word integer. I think this is a great opportunity to visually represent these conversion instructions. Now remember, a double word is 32 bits, and if you have a 32-bit integer, you can kind of see that in your mind. Every bit in that number can be added up to create a very large number. But in single precision, which is 32 bits as well, those who followed the other videos know that these floating point values have a sign bit, have an exponent portion, and then it has this fraction portion. So I can totally see the need for doing such conversions. And Intel gives us the ability to truncate, that is shorten, right? Truncate packed single precision floating point values to these double word integers. So there are times when that will be needed. There's another truncation right down here, but Intel first inserts the CVTSS2SI instruction so that we could get the whole scalar idea going as well. So you can convert a scalar single precision floating point value to a double, and then you can convert with truncation a single scalar floating point value to a double as well. I might have said as well too many times here, but as you can tell, there's this pattern Intel's using for the Chapter 5 instructions. Alright, so the way this MXCSR register works is we have these state management instructions to allow us to save and restore the state of that register. And there's two parts to the register, the control and the status part. Now this doesn't necessarily correspond with the two instructions. The two parts is the control and status part. That's the answer to this question. However, the two instructions is a load an MXCSR register and then the save. And there's really great descriptions on how to do this on Stack Overflow. So if you're feeling so motivated, definitely head over there. And I really don't know anyone who knows more than this stuff than Peter Chords from Halifax, Canada, possibly. I suggest you use him as your go-to resource for assembly and all things x86 related. Well, even x87 related, SSE related. Maybe I should say Intel manual related. Alright, so that's the MXCSR register. Next is the SSE 64-bit SIMD integer instructions. So, yep, we got integers inside these floating point things. It says these instructions perform additional operations on packed bytes, words, double words, all contained in the MMX registers, and they represent enhancements to the MMX instruction set. So in the beginning was MMX, and then came XMM. So the tricky thing about that is it's using the same registers, just there's more of them now. After that we'll get YMM and then ZMM. Okay, but I need to focus. So the instruction PAVGB as in Green Bay Packers, just kidding. But the PAVGB instruction is all about computing the average of packed unsigned integers. And I just have no idea what's going on with this mnemonic. P for packed, I assume. A and V for average. Oh, and the G. Never mind. So P for packed, AVG for average, and B for byte integers without the I. Oh, Intel. There wasn't a PAVGI? That wasn't available? Well, okay, I guess I get it because this next one uses word. So same thing, just a smaller size or larger size. Words are 16 bits, sorry. And look, I mentioned the XMM registers being larger, but the same as the MMX registers. Well, they will keep increasing by size from 32 to 64 to 128, etc. Okay, so I see the P, that's probably for packed, but it doesn't say packed in the description. So we got packed EXT, so extract, and then, oh, the R, man, I really mess these up. So EXTR for extract, and then W for word. Same process down here, P, one word, INSR for another word, and I'm not talking the bits word, I'm talking about like the language word. So the word insert is represented by 4 letters here, and then 1 letter for word. Then we have a packed max unsigned byte. We'll have a packed max scalar word. And then we'll have a packed max signed word. I thought that might be scalar for a second, but no. We have a packed minimum unsigned byte. Same thing, but for a word next. We can move the byte mask around. We could multiply packed unsigned integers and store the high result of that. And then we'll compute the sum of absolute differences, and then we can shuffle the packed integer word in an MMX register. Why you would want to do that, I have no idea. But we are at the end of the video, so let me say this. The SSE cacheability control prefetch and instruction ordering instructions provide control over the caching of non-temporal data when storing the data from the MMX register and XMM registers to memory. So the prefetch H allows data to be prefetched to a selected cache level, and the sfence instruction controls instruction ordering on store operations. So to store an operation, you will sfence it. So we got mask move Q for non-temporal store or selected bytes from an MMX register into memory. Then we have this non-temporal store of quad word from MMX into memory. Non-temporal store of 4 packed singles, again from XMM to memory. Prefetch H means to load 32 or more of bytes from the memory to a selected level of the processor's cache hierarchy. That's awkwardly written right there. 32 or more bytes? We're not talking 32 bits? The last crazy thing we'll read today is sfence serializes store operations. And how about that for our last question? What are store operations? And if you want access to all the questions I've created so far for the Intel manual, specifically the 64 IA32 Architecture Software Developer Manual, you can go to my GitHub here, so github.com/rhoughton/ sorry, these are forward slashes, so / Intel manual, and you can see I have a tiny bit of code I've placed here as well. If the Intel manual mentions something relating to code, I try my best to put it in here. And you all can feel free to contribute to this as well.